So I'm going to do a just a sort of a standard example problem. I'm going to say I've got a charge here that's positive 5.7 nanocoulombs, and I've got another charge here that's positive 3.8 nanocoulombs, and they are separated by a distance of 14.7 centimeters. So, and I want to know where is there no electric field. Well, in the previous video we just said that electric fields point away from positive charges. So there's electric fields pointing out all over the place from this one, and there's electric fields pointing out all over the place from this one. But because they are vectors, at some point in the middle you're going to have a vector pointing this way, and you're going to have another vector pointing that way, and the two vectors are going to completely cancel out, and they're going to give an unstable equilibrium, and at that point there's going to be no electric field. So, well, we have the electric field for a point charge is kq over r squared. Okay, so we're going to have, call this 1, call this 2, and so we're going to have two electric fields, and we want to know exactly where they cancel out. Now, if we just take a guess, we're going to say that it's probably going to be closer to this one than that one, so we're going to probably mark that as our point right there. And then the question is, what's this distance? Well, we don't know that distance. So what do we call it if we don't know it? We call it x. And so then, what do we call this distance? Well, I didn't give myself enough room. I'm going to call this 0.147 meters minus x. So it's going to be, this is 14.7 centimeters, that's x. This is going to be 0.147 meters minus x. And so what I want is, I want the electric fields, I want E1 to equal E2. Where those electric fields are equal, one's going to be pointing this way, the other one's going to be pointing that way, and if they're equal, they're going to cancel each other out. So I'm going to say k q1 over r1 squared is equal to k q2 over r2 squared, and now I get a little bit of cancellation here. I'm going to know that my k's cancel, and what I'm going to do is, I hate fractions. I can't imagine anybody who really likes fractions. I'm going to say q1 r2 squared is equal to q2 r1 squared. And now I'm going to take the square root of both sides. So I'm going to say the square root of q1 times r2 is equal to the square root of q2 times r1. Again, I'm working in symbols, aren't I? Because it's faster. Now, I'm going to say that square root of q1, so I call this 1 q1, so this is r2 This is my R1. So my times x, square root of Q1 times x, is going to be equal, I'm going to call this D, square root of Q2 times D minus x. Still working symbolically because it's quicker for me. Distributing, square root of Q1x is equal to the square root of Q2 D minus the square root of Q2 times x. I'm going to have move this over, so I'm going to get square root of Q1x plus square root of Q2x is equal to the square root of Q2d. And so finally I'm going to get x is equal to square root of Q2d divided by square root of Q1 plus square root of Q2. And so now I'm going to plug in my numbers and we'll see where we get. I'm probably going to run out of space there, so why don't we just continue on to another page. I'm going to say x is equal to the square root of Q2, which is 3.8 times 10 to the negative 9th coulombs. D is 0.147 meters divided by square root of 5.7 times 10 to the negative 9th coulombs plus the square root of 3.8 times 10 to the negative 9th coulombs. And again, now I'm going to crank out all of this on my calculator in one shot, all on one line, which is what I want you guys to do. So, square root 3.8 second EE negative 9, close that square root, times 0.147 divided by, now I need to open a set of parentheses because I've got a plus sign in my denominator, square root of 5.7 second EE negative 9, close that parentheses, plus square root of 3.8 second EE negative 9, close that parentheses, should be all good to go, and I get 0.066 meters. So that is 6.6 centimeters, and that is going to be 8.1 centimeters. And so I was correct that that place where there's no electric field is going to be closer to this charge than to that charge.